Okay, so lesson 4.2.3. I think this is our last 4.2 lesson. Okay, it's been broken up into kind of baby sections, but it's been good. I wouldn't want to do it all at once. So we're going to start with filling in the chart from yesterday. If you can do it without turning back, that's best. However, if you still have to turn back and look, I understand right now. Okay, you'll have to be ready for a quiz next week about it and filling the chart out. But for right now, it's good to just know it. Okay, so if we, radians, did you guys at least memorize those? 30 degrees is pi over 6. And if you don't remember that, if you forget how to get that on the quiz, or if you forget what it is on the quiz, how do we get to it? Multiply by pi over 180. 45 degrees is pi over 4, and 60 degrees. Pi over 3. Okay? So you've got them right there. Know those. Whatever your memory technique is. Now, I'm going to go ahead and draw the triangles down here. If you can fill in the chart without drawing the triangles, that's great. However, if you need the triangles, by all means, use them. And of course, we're going to be using SOHCAHTOA. Let me zoom in on the triangles first. What do you guys remember about a 45, 45, 90? Legs are the same, so I'm going to call them both 1. What about the hypotenuse? Square root of 2 times the leg. So square root of 2. 30, 60, 90. What do you remember about a 30, 60, 90? Okay. Hypotenuse is 2 because it is 2 times the short leg. So the short leg we use as 1. And the long leg is square root of 3 times the short leg. So square root of 3. So if you're not sure how to fill that, if you don't have the chart memorized yet, draw your triangles. Fill in the triangles, and then use that. So, first one, sine of 30, or sine of pi over 6. What is the sine of 30? What is it? 1/2. Opposite over hypotenuse. Cosine of 30. Square root of 3 over 2, adjacent over hypotenuse. Tangent of 30. Okay, square root of 3 over 3 if you just flat out have it memorized, right? If you're doing opposite over adjacent, it's 1 over square root of 3. So remember, I'm accepting of either or. 1 over square root of 3 or square root of 3 over 3. But there's times that one is more helpful than the other. Okay, 45 degrees. What's the sine of 45 degrees? Opposite over hypotenuse. So 1 over square root of 2 or square root of 2 over 2. Do you know it without doing it? What's the cosine of 45? Same as sine of 45, right? So it is also 1 over square root of 2 or square root of 2 over 2. What about tangent of 45? Did you memorize it yet? Opposite over adjacent. 1 over 1 is 1. Can you do the bottom row without using your triangles? Do you remember a connection I made about sine and cosine? How do sine and cosine of 60 relate to sine and cosine of 30? Yeah, they flip essentially. So sine of 60 is going to be the same as cosine of 30. Square root of 3 over 2. Cosine of 60 is the same as sine of 30. 1 over 2. Could we also use our triangle? Yes, opposite over hypotenuse and adjacent over hypotenuse. Remember anything about the tangent of 60? Square root of 3? It is the reciprocal of tangent of 30. So it's square root of 3 over 1 or square root of 3. As I said, I don't have a date set for the quiz, but I'm thinking early next week, 5 to 10 minute quiz, filling out this chart, your triangles, and then also the cosecant, secant, cotangent part of the chart. Okay? It is a very easy quiz to get an A on. You just have to do it. Okay, so moving along today. Given the following right triangles, find the missing sides and angles. So this is using our trig functions here. Okay, this is not related to the chart. How do I know that my chart's not going to be helpful here? Yeah, it's a 37. The first one I see is 37 degrees. That doesn't fall into 45, 45, 90. That doesn't fall into 30, 60, 90. So we've got to come up with a plan B. So find all missing sides and angles. So by the time you get done, you don't have to find, because some are given, but there need to be 3 sides stated and 3 angles stated. You state any missing. Anyone see a good starting point? Can we find the other angle? All 3 angles in a triangle always add up to be 180. Okay, do you guys hear? Does this sound, I mean, this goes back to, I don't know, is it even as far back as elementary? Seems like it should be. Here's 90, here's 37. 90 and 37 is 127. So 180 minus 127 is going to be 53 degrees. That's my missing angle. What's the other way to find that 53 if you want? Because it's a right angle, this works. 90 minus 37, would that have worked? Because if this one's 90, then that leaves 90 for the sum of those two. So you could also have just done 90 minus 37. Okay, we got the easy part out of the way. Thoughts on how to find A or B? My hint is to think of your trig functions. I was just going to suggest you use 37 degrees because that's a given angle, okay? I know I didn't make any mistakes in my subtract or anything. So if we use 37, how does 37 relate to A? A is opposite 37. What do you know that he used 37, the opposite side, and then we can't use B, which means 8. What is 8 in relation? Or what is 8 in this triangle? Hypotenuse. So what connects the 37, the opposite, and the hypotenuse? Sine. Set up your equation. The sine of 37 degrees is equal to A over 8. Because sine is equal to opposite over hypotenuse. Hypotenuse. Says SOHCAHTOA, right? This is an equation, guys. How do you solve this equation? We are going to plug into our calculator in a moment, but before I plug into the calculator, one math step for me. How do you solve for A? Multiply by 8, right? If it's A divided by 8, then the opposite of dividing by 8 is to multiply by 8, which means A is going to be doing 8 times the sine of 37 degrees. Which, notice, I put that 8 out front. It is not 37 times 8 and then doing the sine of it. It is 8 times the sine of 37. And then where do you go from here? Calculator. So, 8 sine 37. I was waiting to hear that. And does your answer match my answer? Get your calculators out and try this with me, please. I know it's basic and easy, however, did we all get the same answer as me? Why wouldn't you have gotten the same answer as me? You're in the wrong mode. Make sure you're in degrees and not radians. So if you get a differing answer, check your mode. So, I'm going 2 decimal places today. So A is approximately 4.81. What about B? I would not. Okay, so the suggestion up here, I understand this, but that's not the design of how we're doing design of it today. She said we could use Pythagorean theorem. I agree with the concept. However, we just rounded this answer, first of all, okay, which can throw off your Pythagorean theorem. And second of all, the point of this is to practice using our trig functions. Okay, so I'm not saying it would give you a totally wrong answer. That's not what I'm saying at all. But I want us practicing our trig functions too. Okay, good thinking. Okay, so her follow-up suggestion is the sine of 53. Is this an option? How would sine of 53 help me? The sine of 53 is going to be b over 8. Could we go with that? Okay. I want to talk about other options though while we're here too. Are there other options? Okay. Cosine of 37, is that an option? Because cosine of 37 is adjacent over hypotenuse. Here's the deal. Pick something that's going to use the b and the 8. Do not use side A. Don't try and use this rounded decimal to help you then find another side. That's just a disaster waiting to happen. Okay? So pick something that uses b and 8. You could use 53 or 37 because that 53 is an exact answer, isn't it? That's not a rounded answer. The only thing I hesitate with on 53 is what if we made a subtracting mistake? It's then causing my other answers to be wrong. But, again, it was basic subtraction, so I'm not too concerned. We don't all have to do the same thing here. Okay? I'm going to put cosine up here just to put a different trig function up here. But all that to say, I don't care if you use the sine of 53. I'm going to use cosine of 37. If I use cosine of 37, it is adjacent over hypotenuse, which is b over 8. Then how do we solve for b? If it's b divided by 8, we need to multiply by 8. So b is 8 times cosine of 37 degrees. Check your calculator. Make sure you know what you're doing. Notice I used 8 cosine of 37. If I had done the sine of 53, notice my answer is identical, yes? So if you had taken the sine of 53 option, identical answer. So either way, b is 6.39 approximately. Okay? Do we have the idea of what we're doing here? Let's try B then. We're given 57 degrees, 90 degrees, and a side length 13. 13. What did you say? 33 degrees? You guys okay with that? Feel like his math is right? You could either do 90 plus 57, which is 147. So 180 minus 147. Or 90 minus 57 makes sense too. Okay. He took the easy angle. Got out of the way. I don't care if we find x or y first. It is a 33. Okay. What did you suggest, Daryl? Tangent of 57. Let's see what tangent of 57 does for us. We do tangent of 57. Tangent is opposite over adjacent. Does that work? Yeah, because it uses 13, it uses the 57, and then it's going to help me find x or y. So I can go with that. So tangent of 57 is 13 over y. And here's the deal. I'll be honest, it's easier when the variable can be in the numerator, but that's not always going to work out for you. So, how do we solve here? What? Okay, so to get the y out of the denominator, it's currently divided by y, we need to multiply by y. So that means I multiply the y to the other side, and then I'm going to have y times the tangent of 57 degrees is equal to 13. And then what do I do to finish it up? Divide by that tangent. So y is 13 divided by the tangent of 57 degrees. Again, practice putting it in the calculator to make sure you know what buttons to hit, right? I'm not saying it's a difficult thing, but oops, can't see mine there. Did you get an answer matching mine? 8.44. So y is approximately 8.44. So what do we have left? We need to find x. How would you like to find x? Sine of 57? Is that an option? Sine of 57 is going to be opposite over hypotenuse. That uses the 13 and the x. So I could go with that because you're going to need something that uses the 13 and the x. Choose the sine of 57. Could we also go up and do something with 33 if you want to? I'm for it, it works. So sine of 57, 13 over x. You've got that x in the denominator again. Just have to do 2 steps instead of 1. So if it's 13 divided by x, we need to times by x. So x times the sine of 57 degrees equals 13. In order to get x by itself, divide by that sign. So x is 13 divided by sine of 57 degrees. What'd you guys get? 15.5? 15.50, so that is approximately 15.5. Did you guys have to do this type of solving in geometry?
Yeah.
Did you? Okay, so it is review of some sort. Okay. Use the whole. Okay, and that would make sense. Yeah, and that's why I said I'm not saying the Pythagorean theorem won't work. You have to use. You want to be careful about rounding, but then I also want you guys. My goal for this lesson is to practice with our trig functions. So. But yeah, I wasn't going to argue that it wouldn't work, but yep. Okay, guys. Talk me through C. I'm doing a lot of talking. You guys do some talking here. Talk me through C. Okay. 90 minus 21 tells me that this corner angle is 69 degrees. We got the angle out of the way. What do you want to set up with this? What? Okay. Give me a function and an angle here. Tangent of 21. I'm going to avoid cotangent just because it's harder to do on the calculator. Okay, I'm not, again, am I saying it's not possible? Okay, I would rather, so I guess as me leading you guys, or as, what I put up here, I'm going to stick with sine, cosine, tangent. Does that mean you can't use the others? Not at all. Okay, just be very careful that you know what you're putting on the calculator. Okay? Okay, so I've heard cosine of 21 and tangent of 21. Those two would give me my m and n, yes? Okay, again, not going to argue you couldn't use cotangent. Meet me in the end with that one. Which one am I heard both. Let me start with tangent. Tangent of 21 is going to be equal to what? Tangent of 21, opposite over adjacent. So m over 14.2. Multiply by 14.2. M is 14.2 times the tangent of 21 degrees. What's the calculator say on that one? I can guarantee it's decimal, but what decimal? Okay. 5.45. The other one that we talked about besides tangent of 21 was cosine of 21. If we do cosine of 21, that's going to be what? Adjacent over hypotenuse, so 14.2 over n. Multiply by n. So n times the cosine of 21 equals 14.2. Divide by the cosine. 14.2 divided by cosine of 21 is 15.21. You could use the other one also. I tend to in my notes stick with the given angle just because my only thing that I would say about using the other one, and again, 99.9% of the time you're going to be fine. What if you made a subtraction error? If you made a subtraction error, that angle's wrong, which is then causing the other answers to be wrong. That's the only slight, and I say very slight, advantage of using the given angle. However, is it sometimes easier just to use your other one? Yes. Only thing I don't recommend is using these rounded decimal sides to find other pieces. avoid that. But the angles come out to be whole numbers, so that's not a big deal. Okay? Now, word problems, guys. This is going to be huge. You've got to be able to do the word problems here as we go through the trig stuff. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. Find the height h of the building. Draw it. Definitely draw it. What shape am I going to be drawing? A triangle is what it ends up to be. Okay. We've got a person. I'm going to say there's a person at this point here. And they are looking up. Here's my building. Okay. There's my person at this point. Here's my building. It says from a point 340 feet away from the base. So what's that mean? Okay. This is 340 feet along the base. The angle of elevation to the top of the building. What's that mean? Angle of elevation? Yeah, okay, it's the hypotenuse. So as I'm standing here and looking up, I'm looking up at an angle of 65 degrees from the horizontal. Okay? So that's saying that this angle right here is 65 degrees. And what do they want to know? Height h of the building. I'm going with the picture was the hard part of the problem. What do we do? What do we set up? Tangent of 65? You really only have one option here. We could argue two options, right? Daryl's going to do cotangent. We could do that. But tangent or cotangent are your only options. My preference is going to be tangent. Tangent of 65 is opposite over adjacent. So h over 340. Multiply by 340. So 340 times the tangent of 65 degrees. What decimal? You have to check and tell me what decimal.
I bet you I can guess it. It's going to be 18. I am absolutely.
Keep in mind, we're multiplying 340 by something.
Yeah. 729. Oh, God.
Okay, guys. These are the problems you're looking at in homework. I expect to see some appropriate work. Don't just give me a page full of answers on this one. Okay, set it up before you give me that answer. Minimum requirements there. The homework was written up there on the side, page 335, 49 to 58, 61 to 65. And keep practicing that chart.